So I am back, and it's been a long time since I have done my last stream. I think it was around midweek of March, and today it's 8 June. So, like, it's been 3 months, and in this time, I always wanted to continue the streams, but sometimes I was busy or I didn't have enough willpower to continue the streams. So eventually, I forced myself today to do this stream, and I will be continuing to do streams every day from now on since it is my vacations. So I will continue with the practice, and I have completed the 1100 rated problems and started the 1200 ones, and also have done its first 6 questions, and they were pretty much doable in the time frame of 1 hour to 1.5 hours. Let's continue. Also, I gave the lead code contest yesterday, and I was able to solve two questions in under 30 minutes, and the third question I was unable to solve. It was a DP problem. DP with optimization. I didn't study that topic. I only studied plain DP, but it was giving time limit error with that. Let's focus on today's question now. As you can see, I also changed my theme to dark in OneNote. 31 1200 playing the casino. Div 2B. Okay. Galaxy, like a well-known casino in the entire solar system, introduces a new card game. In this game, there is a deck that consists of N cards. N cards. Each card has M numbers written on it. Each of the N players receive exactly one card. N cards, N players. Each player one card. M numbers. Each card has M numbers written on it. Card M numbers. Then all players play with each other in pairs, and each pair of the players play exactly once. Okay. Thus, if there are, for example, 4 players in total, then 6 games are played. It's 4C2, 4C2, 4C2. 4 factorial, 2 factorial, 2 factorial. 4 factorial is 4 into 3, 2 into 1, 24, So it's coming out to be 6. Okay. Hmm. The four players, 6 games are played. The first against the second, the first against third, first against fourth, second against third, second against fourth, third against fourth. Okay, 6 games. Each of these games determine the winner in some way, but the rules are quite complicated. Okay, we will not describe them there here. All that matter is how many chips are paid out to the winner. Let the first place card have number A1 to AM. The second place card B1 to BM. Then the winner of the game gets the absolute difference between the cards. Chips from the total pot. Hmm. Total games in C2 and chips win is equal to absolute difference between M numbers of player. Okay. To determine the size of the total pot, it is necessary to calculate the winner's total winning for all games. Hence, there can be many cards in a deck and many players who have been assigned to write a program that does all necessary calculation. Size of the total pot, it is necessary to calculate winner's total winning. Each input consists. Okay. Let's write down the constraint. Eventually, I think the question is asking to calculate the size of the pot. Constraints. So 1000 test cases. N into M is in this range, so we can have a solution of this complexity. What is C? Okay, Cij, card of all numbers written on the card of the ith player. And these are the numbers written on the single card. What was M? M numbers. 5 numbers written on a single card of the first player. This is the second player's M numbers. Here M is equal to 5. M numbers Cij. 3 into 10 to the power 4. Bad handwriting. Hmm. Let's see the test cases to analyze. 50, 0, 31. Hmm. So in first question we have n is equal to 3, m is equal to 5. And the first player's card are 1, let's write it as P1, 1, 4, 2, 8, 5. P2 is 7, 9, 2, 1, 4. P3 is 3, 8, 5, 3, 1. How will we decide the winner? Rules are complicated, winner and somewhere. So it is not revealed that how is the winner chosen. Hmm. Total games possible. Let's write it down. 3C2. It's 3. Okay. First game can be played between 1 2. Second game between 1 3. And the third game between 2 3. Hmm. So I think let's first see the pattern. Let's consider P1 as the to determine size of the total pot. It is necessary to calculate winner's total winning for all games. In the first game, first and second player. The first and third player. Oh, okay. In between second and third player, the winner receives 13 chips. Uh, So this shows that whoever wins, it does not matter. We just have to take sum of all the games possible. Then this is a very straightforward question. But this we consists of NC. How many matches? NC2. This turns out to be 2 factorial and minus 2 factorial. This consists of n into n minus 1 into 2 matches total. First I thought that we will have to make the cases that who will win, but eventually it does not matter. Whoever wins, we will have the same value for the absolute function, and corresponding cards will be subtracted and then added. So we have this as absolute of AI minus BI as some sort of this. I is equal to 1 to m. So A minus B or B minus I, its absolute will give same value. So we will have to perform this calculation. Total matches here possible are NC2, which are n into n minus 1 upon 2 matches, and we will traverse and calculate this chips, which is m. So total time complexity will be for the brute force it is very easy. We just have to subtract and calculate this for all the matches, and all the matches is equal to this. So try all combinations, and it can be easily done with a simple loop. Like we have 1 to n players, first to match with 2, then 3, then 4, this, and reach the end. So first 10 matches are done, then 2, 3, and 2, 4, 2, 5, 2 n, so like that on. So we will have n into n minus 1 upon 2 matches, and in each match, for each match, we choose the corresponding two arrays and then calculate the score. Calculate the chips. And this is the formula to calculate the chips, and this will be done in time complexity of O m, and this will run O n into n minus 1 by 2. So this will pretty sure to give time limit. This will exceed the limit. O of n into m is in time bounds, but this is giving an extra factor. This will be O of n square m. So this will give a TLE. So we have to optimize the we have to remove this n factor. So we have to identify the redundant part. Is it possible to derive the next game's chips using something? Let's see. One common, so player is common. Hmm. Corresponding difference. Seven six. 7 minus 3 is 4. 1 and 3 differences 4. 2. This will contribute 6. This will contribute 5. 0. 7. 1. We will have to traverse all the matches or not. The extra factor is coming from the matches. We can keep this m, and we have to keep this. This is extra. This is 3. This is 2. 3. 1. We select the two indices. Difference x, difference 4. If we go down, then it is 2. We have to sum them all. This comes out to be 11 plus 8, 0. 11 plus 7 plus 19. And this difference comes out to be 4 plus 1, 5, 3, 3 5, 8, 10, 13. How can we tackle this? I'm not getting any idea. And one player, so no. Second player, okay, 0. And this is n is equal to 4. Total matches playable in OC2, that comes out to be, we calculated it earlier, OC2 6 matches. We can mm, if we are at this, we calculated for this too, and if I have to calculate for this 2-3 matchup, then simply subtract the upper row. Okay, and from this information only I want to calculate the upper rows to skip the n minus 1 extra factor. If I go here, it will be brute force. Minus 1 ij sliding one 3 matchup. How will I calculate it from 1-2 or 2-3 matchup? Okay, I have 1-2 matchups here. If this, because this from 4. And we eventually have to calculate the sum somehow. It doesn't matter for, like, if somehow I get the info also, still I will first select for this player, then for this player, which will eventually lead to the brute force solution only, since I will be possibly checking all the combinations. So I have to focus on the sum part, the chips. Okay, n into n minus 1. N matches chips can be calculated easily. N matches chips. total are n into n minus 1 upon 2. Because we can easily calculate the consecutive players matches in of n into m. But then we will have to total number of matches possible are this, and we covered only this much. So the remaining matches will be n into n minus 1 upon 2 minus n. And let's see. Hmm, that are a lot of matches. Any absolute function properties you can define it. Subtract corresponding sum. B and C. We have to optimize this. Hmm. If we go, like we are traversing this one. If we go in this one, let's observe this. Three, four, P4. 1 plus 6 minus 4 is equal to 3. Okay. So we started from this. We track, we keep a separate variable chips. Okay. We calculate the first difference between P1 and we have to P1 P2 match up, P2 P3 match up, and P1 P3 match up. Consecutive, we can easily calculate. Consecutive, we can easily calculate. And the problem is to derive P13 matchup using intermediate P2 to speed up the complexity. If we track, this is 1, then we are doing, then the difference between consecutive is 7. Absolute, we are ignoring absolute now. We are seeing how much the values actual differ. So we plus 6, reach here 7. Currently we are here and we are traversing now in this column major fashion. Then Ri will increase, and we know that 6 this number will be 7. We know this. I want this this matchup done. 1-3 matchup from 2-3 matchup. I know this number will be 7. 7 minus 4, like not 7. 7 minus, no. We need minus 4 to reach 7 to 3. How to know this number without being actually on this number? So minus 4, 3, and 7 itself was plus 6. Three plus 4, Okay. Three plus four minus six for P1, and we can store this using a prefix sum. Let's do this in here. It's been a little messy up there. So I think we will start fresh with same example, because I think we are close to solution. I think first of all, to reduce the time complexity, we will have to use some prefix sums, because eventually we will have to, like, all answers are being added. This also is additive, this also is additive, and the m terms of absolute difference itself are additive. So addition can be easily done using prefix sums. 14285. Seven nine two. Last one is 38531. And we are traversing in this manner, column major fashion, not row major. We are traversing column major. We have a copy here. The end goal is to calculate all these three terms using this I plus 7 minus 3 plus 1 minus 3. Because all, like, three matches, this is for first match contribution, first match. Second match, this is between P2 P3 match. This is for the first card only, P1 P2 matchup, and this is P1 P3 matchup contribution. So we will have to calculate this all terms using only the first column. This is 6, this is 4, this is 2, net is equal to 12. Let's have some prefix, some array. One based indexing for now. J is equal to j is I plus 1, starts from I plus 1. Then it calculates consecutive difference. We have a chips variable and it adds its in plus 6 here and store plus 6 here. Then our j advances, it comes to 3, and we calculate the difference and it turns out to be minus 4, absolute of which is 4, and we 6 minus 4 is 2. 6 minus 4 is 2. Okay. So we will also have to add this number, like this 2 gives us info of absolute. Let's remove this absolute. 3 minus 4 plus 6 using the prefix sum. Prefix sum 1 is 1. And prefix sum for this is plus 6. And now we are at 3. The difference between 7 and 3 is 3 minus 7. This is prefix sum I minus 1 plus and 7 minus 1 plus 6 I just want to know this number from but if there is an intermediate, how can I then calculate? Okay, that will be calculated. How can I calculate? The question is good, simple to understand but difficult to optimize. we store just the story plus 6, which is def of 2 minus def of 2 plus here are 3 minus here are 2 def of 2 plus def of 2 what this number tells. Difference of 1 is 0. So 0 plus okay. Okay. Then we add first this. If there was we can calculate the sum. These are the sums. Hmm. 1 2 matchup and 1 3 matchup, but we are leaving this. We calculate only for consecutive. Let's see for this case. this is 3 minus 1 is 2, 1 minus 3 is minus 2, and 4 minus 1 is 3. If we go in this manner, so all possible combos with the card M is equal to P1, P2, P3, P4. First match and total 6 matches possible. P1, P2, P1, P3, P1, P4. Then we have P2, P3, P2, P4. Then we have P3, 4. Total 6 matches possible. And if we only talk about the sum of for this column, it will be 1 minus 3 absolute plus 1 minus 1 plus 1 minus 4. This is for all this, and I am writing in this same order of matchup. P2, P3 is 3 minus 4 plus P2, P3 is 3 minus 1. This is 3 minus 4 plus 1 minus 4. 2, 0, 3, 2, 1, 3 turns out to be 2 plus 3, 5 plus 2, 7 plus 1, 4, 8, 9. We have a difference as 0, 1, 2, 3. Let's go 1, 2, 3. The difference between them is 0. Difference between them is 1 minus 3 plus this turns out to be minus 2 plus minus 2 minus 4. This is plus 2. 3 minus 1 is plus 2. This is minus 2 plus 2, 0. This is plus 3 and previous is 0, so this is plus 3. So we get all these matches, but we also want these. This solves a problem of but we also want P to P4 match, P to P3 match. We can also calculate these also because these are consecutive easily, but for non-consecutive ones we have to derive some way. This is also consecutive. P to P4 match. Contribution is 1. P to P4 match. 4 minus 1. Absolute difference. I will try till 8 o'clock, and if I am unable to figure out, then I will end the stream. I will discuss the optimization tomorrow. In that case, it has to be something from prefix sums because we are summing up a lot of things. How to derive this quantity 1? Good question. It does not use any advanced concepts. It's purely logical and logic based, mathematical based question. Just I think I will discuss this tomorrow. Good question. I will discuss the solution optimized version tomorrow, and let's end the stream.